Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. In this lecture, we are going to find the eigenvalues and eigenvectors for the given matrix. So this is an overview to find the eigenvalues and eigenvectors. Now let us find the eigenvalues and eigenvectors of this matrix. A is a matrix of size 3 by 3 with 3 rows and 3 columns. To find the eigenvalues, we require the characteristic equation. Characteristic equation is denoted by determinant of a minus lambda I equal to 0. This is called as characteristic equation. How to find modulus of a minus lambda I and equal to 0? From the given matrix, from the diagonal elements, subtract the lambda from the diagonal elements, remaining all elements write down as it is and find the determinant. We get the characteristic matrix A minus lambda I and find the determinant and equate it to 0. Right. So on finding the determinant, we get a third degree polynomial in terms of lambda. So we can write this as product of three first degree polynomials, lambda plus 3 into lambda minus 5 equal to 0. So on simplifying this, we get three eigenvalues. One is minus 3 comma minus 3 and 5. So here we got repeated eigenvalue minus 3 and 5 is another eigenvalue. Altogether we have minus 3 and 5, two are eigenvalues, among which minus 3 is repeated. While you calculate this in calculator, scientific calculator, we get only two eigenvalues, say minus 3 and 5. Only these two will be displayed in your calculator. That means any one of the eigenvalue is repeated. How come we know whether minus 3 is repeated or 5 is repeated? Means there is a property of eigenvalues. The property is sum of eigenvalues is equal to trace of the matrix A. For the given values, trace means add all the diagonal elements. Minus 2 plus 1 minus 1. So this should be equal to minus 1. That means minus 3 should be repeated. Minus 3, 5. If you add all the values, you have to get minus 1. So minus 6 plus 5 minus 1. So we can say that minus 3 is repeated 2 times. If you take 5 is repeated 2 times, say 5 comma 3 minus 3. If you add all the values, you won't get minus 1. So that means minus 3 is repeated. So we got two eigenvalues minus 3 and 5, among which minus 3 is repeated. Now for each case, lambda equal to minus 3, we have to find eigenvector, and lambda equal to 5, we have to find the eigenvector. Let us calculate the eigenvectors. To find the eigenvectors, we have to consider this equation A minus lambda into vector equal to 0. So among the matrix A minus lambda I, substitute lambda is equal to first case minus 3. Here you substitute in this matrix, substitute lambda equal to minus 3, we get this matrix. Now we have to convert this into equation, solve them, or we can reduce the matrix into echelon form, and by back substitution, that is by Gauss elimination, we can solve the equations and find the solution. So these are the row operations, and I am converting the matrix into row reduced echelon form. So this is the matrix we got. Here second row, third row completely we got zeros. Only one row we got. How to write this in the form of inequation? x1 plus 2x2 minus 3x3 equal to 0. There is only one equation and there are three variables. That means choose n minus r variables as constants. Here n means number of variables 3, r is the rank of the matrix 1, because number of non-zero rows in the matrix is 1. So rank is 1. So r equal to 1. So we have to assume arbitrary constants, two variables x, y or y, z or anyone. So let us take here x1, x2, x3 are the variables. Among these three, choose any two variables as constants. Let us take x2 is equal to some k x3 is equal to some k. Substitute x2 and x3 in this equation. So what you'll get, x1 is equal to 2 minus 2x2 plus 3x3, isn't it? So minus 2x2 plus x3 is x1, this is x2, this is x3. Among this we can write, first take x2 common, so minus 2, second 1, there is no x2 here, 0, plus take x3 common, we get 3, 0, 1. So first vector is minus 2, 1, 0 is eigenvector, and 3, 0, 1 is another eigenvector. v1, v2 are the eigenvectors corresponding to lambda equal to minus 3. We got 2 eigenvectors because lambda equal to minus 3 is repeated twice. Similarly, we have to find the eigenvector corresponding to lambda equal to 5. Now let us see this. Again consider this case, lambda equal to 5, then write down the matrix A minus lambda I into the matrix V equal to 0. So in this matrix substitute lambda equal to 5, so we get this particular matrix and equate to zeros. Again, by reducing into echelon form by back substitution, by Gauss elimination method, we have to find the solution. So using these row operations, I have reduced the matrix into echelon form. On reducing it to echelon form, we get x1, x2, x3 in this form. If you take x3 common, minus 1, minus 2, 1. This is eigenvector. Similarly, we can take 1, 2, minus 1 also, nothing wrong. So these are the two eigenvectors corresponding to different eigenvalues. Thank you.